would you calculate as P1 the true proportion of yes yawn C people who actually yawn?
0.29.
Remember, we want the whole thing, remember, because we want the number of participants there. 10 over 34, which is equal to 0.29. So P2 was the true proportion of no yawn C people who actually yawn. 4 out of 16 equals 0.25. Is there a difference? Does there seem to be a difference? Yeah, it seems like there's a difference, right? So we compared the proportions, there's a difference. So the difference in proportions would be 0.29 minus 0.25 is equal to 0.04. Do the data provide some evidence that yawning is contagious? And why? What do you think?
I said yes because P1 equals 0.294 and P2 equals 0.25, so it is plausible that yawning is contagious to an extent.
But that's like so small.
But like it's no different.
So that's what we get into when we're talking about statistics. And so let's not think about yawning for a minute. Let's think about like cancer growth for a second. So let's say let's say you gave half the people a new cancer medication and the other half of the people like current treatment. And there was a 4% difference. Like it was 4%, it was effective in 4% more of a given group. Would that be something that you would want to pursue? Like as maybe this is a thing?
Yes.
Yeah. Okay. No, this is just yawning. But so
It's not higher because it definitely seems like it would be way more contagious than like some 0.25.
yes, exactly. And so that's the question that we're going to answer here is, okay, it seems like it should be higher. But does our particular result, our difference that we got, is it actually significant in comparison to random? Because maybe you got 16 people who are just yawny people. Like they just yawn a lot. And so maybe the true proportion of people who didn't know yawn seed and yawn is a lot lower than this, but we just happen to have a group of 16 that they were just tired. That's why we always evaluate our results against what if it was purely random. That's why we run the simulation, which is what we're going to do in a minute. Yes?
Okay, this is like a little unrelated, but like does that mean that like the 10% rule, like wouldn't that mean that the prime like sample size would be the sample size that's like one right below what doesn't satisfy the 10% rule? Because
And
it's
remember-
like most people, but like it's so much in the population.
Yeah. So, and that's why we adjust for sample size when we do standard deviation and things like that, because there's an understanding that, yeah, there's variation in sample sizes. That's why sample size is bigger. But a lot of times when we're considering sample size, we sort of generalize it, right? So we say, is 150 students less than 10% of a large high school? We may not be able to measure all of all of everything like population or anything like that. That's a good question. So do you agree that there's a conclusion to be had here? Madison says no. Who says no? Who said no, we can't really reach a conclusion here? Who said yes, a conclusion can be reached? Who was non-committal because they only brought a pen and didn't want to mess up their notes?
Well, I
Okay.
was like it's possible, but I didn't say like for certain. You know? It
No.
says some, and I have.
So the answer should be no, because a difference of 0.04, it doesn't seem like enough difference. This was kind of Madison's point. It doesn't seem like.
So if this was a question and we put yes, it would be wrong.
Even if you like valid
But, like,
explanation for it.
Because
Doesn't it depend on sample size?
So here's the thing.
Yeah.
This is a conceptual question. This isn't necessarily one like you'd see on the AP test, unless they gave you more information where you were running a test. Okay, so they'd say, so I'm asking you this question now. I'm going to ask you this question again after we run the test. So on the AP test, let's say this exact question shows up, and they use this data to conclude that yawning is contagious. Do you agree? What you would say is something like this, and this is what Anika and I were going to talk about. You'd run the test and you'd say, no, because by chance you would get a difference of this 20% of the time. So it's not that uncommon to say it. So we're trying to answer this question without all the information we would need to make like an informed response. That's why this response here kind of is like a feeling, like it doesn't feel like that's enough. Well, we don't have the mathematics yet. We're about to do the mathematics right now. Does that make sense?
What does it say? 'Cause I can't really.
Yeah. So it says, no, a difference of 0.04. It doesn't seem like enough difference. It doesn't seem like enough difference. Because, and it doesn't seem like enough difference. We don't have the math yet. So we're about to do the math. All right. So flip over the page. So here's what we're going to do. Basically, what I'm going to do, I'm going to give you some cards, and we're going to flip them over, and we're going to do a random game. Meaning, we are going to have cards that say yawn, no yawn. You're not actually, it's not like you're going to flip over the yawn card to go, oh, okay, it's not like that. What this card simulation is designed to do is designed for you to, like, you're just picking a card. And there's a certain proportion of them that say yawn. And so that would be the person, they yawn. Okay, so we're going to walk through, but that's basically the simulation. So, in this activity, your class will investigate whether the results of the experiment are statistically significant or if they have occurred purely by chance due to random assignment. So what's the null hypothesis here? What would be our null? What are our options for our null hypothesis?
Yawning is contagious.
Yawning is contagious. Okay. How do we mathematize that?
I'd be like,
The proportion of people who yawn after the group is given a yawn suit or increase compared to the group
Are we
that didn't
basing
receive
it
a
Ah,
yawn suit.
hold on. What did you just say? He said increase. Increase implies
Change.
same, so change, which implies difference. Right now, so we've been talking about proportions, and we've sort of been building this way. Last chapter, remember what we did? We did proportions, then we did difference of proportions. Guess what we're doing today? We just did proportions with hypothesis testing. Now we're going to do difference of proportions in hypothesis testing. So a null hypothesis, in this case, we're going to set it at 0. We're going to set the difference at 0. I want you to think about that for a second. So what are the two proportions that I'm dealing with? We try to make it easy. It's literally p sub 1 and p sub 2. My null hypothesis is that there's going to be no difference. So what we're going to say for our null hypothesis is h sub 0 is equal to p sub 1 minus p sub 2 is equal to 0.
piece of one minus piece of one.
2. Yeah, you're right. Thank you.
Do we have to put the hats on it or no because it's the true proportion?
True proportions.
And is that always the null hypothesis for a difference question?
That's what we're talking about with differences. Yes.
So it's always gonna be that.
So we're going to say that there's no difference. And so the alternative hypothesis would be what?
Not
There is a difference. Okay, that there's not equal to 0. And so I want to write down a little interpretation so you can remember. This would mean that the yawn seed does not affect whether a person yawns or not. It does not affect whether a person yawns. Here's how we're designing the experiment. So check this out. What are we evaluating? If our h sub 0 is that there's no difference. Our alternative hypothesis is that there is a difference, or in this case, we're evaluating the Mythbusters claim. What's the Mythbusters claim?
The yawning
That yawning is contagious based on what?
is
Their sample, which gave them a difference of what? So let's just look for a second right here. Let's say, who did this dot? Somebody have 0.5?
I have 0.04.
Yeah, so, okay.
Oh wait, no, 0.4.
Point-
Yeah, not 0.4. Sorry.
Okay.
I got this.
So really what we're saying is, what's the probability that the Mythbusters got 0.04 or more by chance, right? Because think about it like this. Let's say you run this experiment. You get a difference of 0.4, and Madison's like,
No,
let's
it
put
was
this.
0.04.
0.04, yeah.
You're right.
Yeah, so 0.04. So let's say you had that difference of 0.04, yeah? Well, then Leon comes along and he's like, no way. I don't believe it. That's way too close for me. I'm going to run my own experiment. So he does the exact same experiment with 50 other people, and he gets a difference of 0.29. Okay? Is that more convincing evidence that there's a difference or less?
The same.
Wait, if you don't.
Is it more convincing to get 0.29 or 0.32
Yeah.
or to get 0.04 as the difference?
Convincing for.
So think about it like this. As we move this way, I'm going to put it in quotes, more convincing. That make sense? It's more, the bigger the difference in proportions, the more convincing that it is. So think about what the Mythbusters did. They set it at 0.04 and they said, oh, there you go. That's convincing to me. I am convinced. And so that's where we're setting our level right now. So really what we're doing is evaluating what's the probability that the Mythbusters got 0.04 or more purely by chance. Does that make sense? Because if the Mythbusters were willing to say 4% is convincing, surely they'd say 32% is convincing. So what we're saying is, what's the percent chance that they got 0.4 or more, 0.04 or more purely by chance? Yes?
Is there a dot like right next to the 0 on the right?
Yes. So what we need to figure out is, well, what is that probability? And really, honestly, it's kind of easy for us because we don't have that many dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So our denominator is 28. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 of our 28 dots were at the level that the Mythbusters said, I'm convinced, or greater, or more convincing. Does that make sense? And so, what conclusion can we make about whether yawning is contagious?
It might not be because there's
It's likely to
because
happen
it's
by
really easy to get that right.
Do we have like an alpha of words?
What's that?
Do we have something to like a number to compare it to?
Ah, good question. Let's compare it to 5%. What do we got? What is our p-level? What's our p-value?
So 0.64.
This is our percent value right here.
0.64.
Because 0.64 is greater than 0.05. Therefore, we
deem it significant.
what are we saying?
You can assume it's
Yeah, we can't reject the null. We fail to reject the null.
I hate that one. We fail to reject.
When the college sent you a letter, we
We failed to reject you from our institution. Thanks.
So- Okay? So we fail to reject the null because what we're saying is there's a big chance in our data, a big chance that we got 0.4 or greater purely by chance. So it could have just happened. Does that make sense? Are you with me on that?
Yeah.
So 0.04 could have just happened by chance. In fact, we said compared to the 0.05, woof. So if we fail to reject the null, what was our null?
difference equals 0.
So think about that for a second. It's above the alpha level, so we fail to reject the null. Meaning, if we had accepted the null, let's just say that fail is the opposite of accept. If we accept the null, what would we say? If we accept this,
That
The difference would be 0.
that planting a seed does happen in the time.
We
Yes.
do not have enough evidence to
Okay? And do not we do not have convincing evidence that yawning is contagious because their results could have happened by chance. A lot.
Or what?
Could you say that we got those results? Oh wait,
So if
like over half the time or something? Like just because it's so many, like the by chance, like over half of the time we got more than
but
And this could be anything, right?
That's what
Because
I-
like this could have fallen anyway, but what happens is we say that this it happens by chance. Like our simulation showed that by chance that could happen a lot.
okay, so the null, if we reject the null, it says that it means that we think that there's a difference.
I think Chloe asked this question, or maybe it was Lex. I forget some of the table. So here we go. When we're dealing in difference of proportions, here's our null. P1 minus P2 is equal to 0. And in parentheses, so that would mean, just as a reminder, that they would be equal. So to say P1 minus P2 equals 0, you're saying that they're the same. They're the same. There's no difference. So then our alternative hypotheses can take one of three forms. Either P1 minus P2 is less than 0, which would mean that P1 is less than P2. So if our difference is negative, that would mean our second one is bigger. If our difference is greater than 0, that would mean that our second one is smaller. Or we could say, this was our two-sided test, remember? When we talked about just not being equal. So what we're saying is there is a difference versus there isn't a difference. Let's talk about our conditions. 1, is it random? So if we have a random sample, and this is kind of a blast from the past, this is us being reminded. If we have a random sample, that means that we can generalize our findings. And or random assignment. So that would be in the experiment itself if we randomly assign what's going on. And that allows us to talk about causation. Does a particular treatment cause something? But it has to be randomly assigned in order to do that. %% condition. In these cases, we're only going to check when we're sampling without replacement. And this is the one that's really important. Well, they're all really important, but there's an important piece to this. We check large counts. Remember back from last chapter when we had two proportions, what do we have to do to determine large counts?
All four.
Check both. Check them all. Okay, check for both samples or groups. So check for both samples or both groups.
So if we don't like show that we did the work for, like, are we supposed to show that we tried those conditions on all the problems that say that
Yes,
they're normal?
so we're going to do that now for this problem, for this particular problem. Okay, so I'd like for you to walk through the check your understanding. The experiment is outlined, and so you're going to do the state and plan portions for that particular outline. The parameter that we're measuring is the difference in proportions, and so kind of keep that in mind. Statistic is what we actually came up with when they did the experiment. And so then I want you to go through the alternative hypothesis. Write the alternative hypothesis from the Mythbusters perspective. Okay? So go ahead and try that. I'll give you a few minutes to do that. So our parameter is P1 minus P2, which, notice I didn't put the hat.
Is that equal to each other? Because it's true.
No, so that's going to go down here. Hypothesis is going here. So this is the true difference. And remember, our parameters always talk about the whole thing. Statistics talk about the specific case. So if our parameter is talking about the whole thing, then this is going to be the true difference in proportions. Of people who yawn. Okay? Of people who yawn. And one of the things that we have to be sure to do, and really it's going to be a reminder for you, how do we measure the, there was the yawn seed right there.
Every time someone says it, I yawn.
There was,
Yeah, the video said it like
Oh, I just yawned.
Oh.
Don't
Don't care if you yawn, don't say the word.
Someone called me not.
Can we call it the Y word from the
Why would
I'm
Okay.
tired of it.
So, as a reminder to you, because it is significant the way that you take the difference, so we're going to put ourselves a note here. What we're measuring is P1 minus P2, which is the difference between the Y seed versus no seed. Yeah.
So do you think the reason that it was only like 20% or something is because it's like the placebo thing, so like we just think it's contagious, so like we purposely make or something? Subconsciously? If it's not contagious? Like I'm just confused. Why it's not higher? Because every time they yawn, we all yawn. But
I
they
don't know.
just didn't feel that.
It might have been because we were thinking about it. I don't
That's
know.
what I'm saying. I wonder if we just like know that we're supposed to be yawning, so we do.
I don't know. Or you could be one of the people. Maybe we have a high concentration of people who just, like, it does affect them.
Just yawn.
Who knows? I don't know. Okay? So our statistic, that's a good
There's
question.
probably just more oxygen in their room than ours.
Could be. I don't know, we got a lot of air coming in through here. Lots of air coming into the vents. Like a jet engine. So P1 minus P2 was 0.29 minus 0.25, and the difference that we found was 0.04. That was the difference that we found.
So you have to put the hats on both of them? Or?
I need to have this. Yes, because it's statistic.
I want a hat. I really wanted to wear my bucket hat to school today, but we can't wear hats to school.
Oh, that's a Valentine's Day dress. People still
Right.
do it.
People
every
don't
time.
do it.
You
You
can't
can't wear
wear
red jeans to school with half the girls at school.
Well, I wanted to, but then there was like, dang, nah.
I don't need to expose them. They expose themselves.
Been here since I was
Literally.
It's just
Don't
fun.
you wear ripped jeans?
Not anymore. I got a pair of high-waisted jeans and they don't have rips, so I wear these.
There we go. So what I like to do with these is I like to not only give the numeric part, but sometimes it can be helpful for you to write out what it actually means. So if I write that H sub 0 is P1 minus P2 is equal to 0, that would mean in my mind that yawning is not contagious. My alternative hypothesis, writing this from the Mythbusters perspective, is that P1 minus P2 greater than, less than, or equal to 0. Yeah. Here's the reminder. Yawn seed, sorry, Y seed versus no seed. Yawning, trying, is contagious. Our significance level, what did we set it at?
0.5.
And you guys like to say that fish equals 0.5.
Wait,
Okay,
what's that symbol?
what's that?
Alpha.
Alpha.
Omega.
New warning, new test coming up. 2 sample.
I can't remember the name of any of them.
Z test. Two sample Z test.
If he stays longer than April, he'll be illegal.
2 sample Z test for P1 minus P2.
Wait, how's it different from chapter 8? Chapter is 2 samples Z test interval?
Yeah, because we're making a confidence interval. All right, check conditions. 1, random. Check out how we look at this. They randomly assign. This is important. Listen to this. Don't be distracted. So, it's random assignment, which allows us to talk about causation. Does yawn seed cause yawning?
Oh, I hate the word.
2, our 10% condition. What do we put here?
10 no, 50 is less than
B times N. Oh, must be less than 10% of the population.
Did we pull a group from a population?
yes.
Wait, they didn't. But the world?
It's a population of all the people.
But then that would have bias because only the people with that like market.
All right, so
So we can't do it?
yeah, so we don't have to check it in this case because we don't have sampling here. It's not sampling. It's an experiment.
Wait, how's that?
But I thought it
how
was-
is
It's
it
not like
simple?
not good though. But you select a random sample for your experiment.
Is that
But you select a random sample for your experiment.
they randomly assigned?
Yeah, but we
Wait,
don't have
did
a
it-
population.
Isn't
for
the
it to
50 a
check against
sample from
10%
all
of the
the
population.
It is, but they were all part of the
So
experiment.
you can't multiply it.
Sampling would be
Okay.
taking
You
some,
don't
but not
have
others from that
No.
particular experiment.
Wait.
from
Yes.
the world.
Then don't you just assume that it's 10% less than the population of the world?
Exactly. Yeah.
Instead of saying
Yes, but you don't have to. We
Okay,
don't
but-
have to check it here.
Okay.
Yeah,
What if
but
it was like-
you still have
What
to
if it
think
was like
about
all high schools at Prince Peace? Like we try to check. I know it sounds stupid, but like if yawning is contagious only at Prince Peace,
Yes,
so you have to.
that would be different.
I'm just gonna put it anyway until I get to the
There you go.
It's scared.
We're not going to talk about large counts right now. That's going to be in the next lesson. Yes.
So like I understand the 10%, like, but why is this type of experiment like able to do that and not this?
Great question. Flip the page. That's a great question. So in our next lesson, here's what we're going to do. We are going to actually do this. And you're actually going to test some conditions in a particular scenario. And you're going to see what the difference is. We're going to see what the difference, like, why is this not 10%? What is, like, when would I do 10%? So here's the scenario. You ready? Beautiful continuation. The student council at a large high school, so immediately in your brain you should think, okay, large high school, okay, is wondering if juniors or seniors are more likely to attend prom. They take a random sample of 50 juniors and find that 28 are planning on attending prom. They select a random sample of 45 seniors and 29 are planning on attending. Do the data provide convincing evidence that a higher proportion of seniors are going to prom than juniors? Use a 5% significance
How do
level.
we do this?
What's that?
How do we do this?
We did this, but what's the difference in this that we're doing now?
What is the portion
We're- Difference in proportions now.
That's what she
Okay.
said.
Difference in proportions. So here's what I'd like for you to do. Start walking through. Start walking through. I'd like for you to do the state and the plan.
Do the data provided with evidence.
Data, plural
That's
data.
what I was saying.
Isn't that daytime?
Yeah.
What, is it daytime like a lot of data?
No, daytime is a singular
Do the
piece of
datas.
data.
Oh, so like data means one and then
Do the
data.
No,
data.
data means a lot.
Do the data provided.
Like a
Data means
singular
what?
something.
Data means what?
So they're like
I'm
different
so
words.
sorry, we got so.
Close to this point. Two sample Z test.
Wait, okay, so when we do conditions, you put to be continued on large counts, and I think I know why. Because now I have 0 and that's not a thing.
So here we go.
So,
We're gonna walk.
okay.
Let's do it. So here's the thing. What are we saying in our? Well, hold on. Let's go step by step. Number one. Is this like what is random in here? Is this a random assignment? These are random samples. Where does random assignment come in?
They don't have.
They select a random sample.
Why was
So it is random.
the previous different? Why was it a random assignment?
Because
So
there's no
you
sample.
gave them a treatment.
It was an experiment. You gave him a treatment. Is this an experiment? No, what is this?
Observation.
This is yes. Okay. Observational study. So when you consider random, it could be random sample, random assignment. It could be random sample, it could be random assignment. This one doesn't have assignment. All we did was ask. So this is random, and this is random sample. And as a reminder, when we randomly sample, that allows us to generalize about the population. I kind of primed this with you earlier when I said, why do we randomly sample? We wanted to represent the population so we can say, oh, hey, I randomly sampled some Prince of Peace students. Now I can talk about all of Prince of Peace. Whereas if I don't randomly sample, then I can only talk about whatever particular class or demographic group, whatever. Okay? Number two, 10% condition. We're dealing with two different groups here. So we need to check a bunch of things. 10% condition. So 50 juniors, it's a large high school. So we're going to say they went out of their way to say large high school. So we're going to say 50 is less than 1/10 of all juniors. Check. And we're going to say that 45 is less than 1/10 of all seniors. I don't want to do that. Number three. Here's where it gets tricky. What are we largely counting? And when we've done proportions in the past, we've done something like this, right? NP greater than or equal to 10, N 1 minus P greater than or equal to 10, right? We've done that. Well, the difference in what we're going to do right now is this. We already know the proportion. And so if we multiply the proportion by the population, what are we saying? That would just give us what we had, right? Just the number of people that we had. When we have a hypothesis test, what we are going to do is we're going to call it P hat sub C. And P hat sub C is going to be the total proportion that match what we're trying to measure. In this case, what are we trying to measure?
Senior, or if seniors are not
Going to prom. That's what we're measuring. What proportion went to prom? And so we're going to do the total. So here's what it's going to look like. In this case, P sub C, or P hat sub C, is going to be equal to 28 plus 29 over 50 plus 45. Now, why would we want to do that? Well, we are saying, let's say it doesn't matter if you're a junior or a senior. What proportion would go to prom anyway, right? What proportion would go to prom anyway? The only way to find that from our P hat is to combine the actual two samples that we have. We're going to compare to that. That's what we're going to use for our large counts. Because that's saying, what if it didn't matter if you're a junior or senior? What proportion of people actually went to prom from our samples? And so in this case, we got 57 out of 95, which was 0.6. That's what we're going to use for our large counts. So we're going to do 0.6 times 50. And we keep going down the line. We're going to do 0.6 times 45. Oh, sorry. So I have to check all these. So we're still doing proportion and 1 minus proportion, but we're going to use the cumulative of all people that went to prom, assuming that it didn't matter, which means that's going to support H sub 0. So assuming that it didn't matter, pooling them all together. I don't want to leave you floating here. This is N2. And what you're going to find there is that all of them match, meaning they're all greater than 10. What does large counts allow us to say? The distribution is normal. Okay, we're going to pick up there next time.